So, hello everyone. Today we're going to explain what is process capability. We're going to understand what is CP, CPK, PP, and PPK within minutes. So, process capability is the most important concept in the journey of Lean Six Sigma. If you cannot understand whether your process is capable of meeting the requirements of the customers or not, then you are on the wrong track. So, to understand whether your process is capable of meeting the requirements of the customers, you need to find out process capability. So that is why this concept is so important. So we are diving deep into this concept of process capability with CP, CPK, PP, and PPK. Everything we're going to explain in details. So now I'm moving into that what is process capability. Process capability measures how well a process fits within the specification limits. It tells you how capable your process truly is. Actually, customer gives you USL and LSL, that is upper specification limit and lower specification limit. And your process will also have some specification, that is UCL and LCL, that is upper control limit and lower control limit. So your process, if the process spread is less than the what customer has specified, then what will happen? You will be able to meet the requirements of the customers. Otherwise, your process will not be able to meet the requirements of the customers. That's why it's very important to find out process capability. So now I'm moving into that why process capability matters. Process capability is very important because it ensures consistent quality, it reduces defects, it builds customer trust. A high capability gives a strong competitive edge. For all these reasons, we need to find out process capability, and that's why process capability is so important in the journey of Lean Six Sigma. Hello, this is Surajit Banerjee. I welcome you all to our channel, the Lean Six Sigma World, your go-to place for mastering Lean Six Sigma. So now I'm moving into that what is CP? CP is nothing but it is the potential capability. It is a process capability. It measures the spread, assuming process is centered. So while we calculate the CP, we assume that the process is centered. Basically, for calculation of CP, we take basically the short-term data. Normally, our days or weeks data we are taken into consideration, and 30 to 50 data points we are basically taken to analyze the calculation of CP. So this is the formula of CP, that is USL minus LSL divided by 6 sigma. USL is the upper specification limit, LSL is the lower specification limit, and sigma is the standard deviation. 6 sigma is a natural process width. Natural process width is 6 sigma. So 6 sigma is nothing but UCL minus LCL. So CP should always be, it can be equal to 1 or should be greater than 1. If it is less than 1, it will not be able to meet the requirements of the customers. That's why CP should always be greater than 1 in order to meet the requirements of the customers. Now I am moving into what is PP. So PP is nothing but it is the process performance. It measures the spread assuming the process is centered. The only difference between CP and PP is that in CP we basically take the short-term data, but in PP we basically take the long-term data, mainly 2 to 3 months data we are taken into consideration. And in CP we take 30 to 50 data points for analyzing the calculation of CP, but for PP we consider 200 to 300 data points for the calculation of PP. This is the formula for PP, the same USL minus LSL divided by 6 sigma. Here sigma is for long term, and in CP the sigma is for short term. That is the only difference. Now I'm moving into what is CPK. So if is CP finds suppose it is greater than 1, so you can say the process is capable of meeting the requirements of the customers, but you cannot confirmly say whether the process is centered or not, because in CP calculation we assume that the process is centered. So CPK, it is the process capability index. It measures actual capability. It measures the spread along with the shift. It shows how close process mean is to the specification limits. This is for short-term data points to basically find out CPK. This is a process capability index. So CPK, the formula is minimum of these two, USL minus mu divided by 3 sigma and mu minus LSL divided by 3 sigma. So that is basically in CPK we find out CPU and CPL. So minimum of these two you have to take into consideration, because the minimum of these two will give you the actual process capability. If you consider the bigger, higher value, then you might say the process is capable, but actually your process is not capable, because the minimum of these two will give you the actual result. Because here we find out how far is your mean from the specification limits of the that is being specified by the customers. So USL minus mu divided by 3 sigma. Mu is your average or mean value, sigma is standard deviation, and mu minus LSL divided by 3 sigma, that is nothing but your CPL. So we find out CPU and CPL, and minimum of these two we are taking into consideration to come to a conclusion whether what is the actual process capability. Now PPK, the same concept for PPK. It is basically the process performance index. Here we take the long-term data points we are taken into consideration for calculation of PPK. It measures again actual process performance. It measures the spread along with the shift. It shows how close the process is to the specification limits. So PPK formula is also same. Minimum of these two you have to take into consideration. Here the sigma is basically for long term, and in CPK the sigma is for short term. That is the only difference. Now CP versus CPK, the key difference. In CPE, calculation of CPE, we assume the process is centered. But in CPK basically takes care of the shift, whether a process is shifted from the mean or not. That is being taken care of by the CPK. That's why CP is a process capability, but CPK is a process capability index for confirming whether your process is centered or not. We need to find out the CPK. Same goes with PP and PPK also. Now good CP and CPK values. If it is less than 1.33, then it's in its improvement. 1.33 to 2, it is industry acceptance, and greater or equal to 2, it is a world class. So if it is less than 1, CP or CPK means your process is not meeting the requirements of the customer, so it is not acceptable. And always remember, CPK will never more than CP, because in CP calculation you find out USL minus LSL divided by UCL minus LCL, so it will always be greater than, because the total spread we are considering. But in CPK calculation, we are only considering whether how far is your mean from the USL and LSL. That's why CPK value will always be less than CP. That is the most important thing. Now, common mistakes to avoid in process capability. So, ignoring the process stability, using the CP alone without CPK consideration, and not aligning with customer specification tolerance. Whatever customer has specified, we can, based on that we can find out CP. But if we just ignore the CPK, because if you don't consider whether the process is centered or not, then you will make a big mistake. CPK might be good. You can say the process is capable of meeting the requirements, but whether CP can be good, but CPK, is it giving you proper result? So if you ignore the CPK, then you will have a problem. That is a common mistake in process capability. And the final takeaway, CP shows process potential, CPK shows the actual performance. So always check process stability first, whether it's process capable of meeting the requirements of the customer or not. That for all these reasons, you need to find out both CP, CPK, PP, and PPK as well for short-term and long-term data. So if you found this video helpful, make sure to like the video, share this video, and subscribe to our channel and turn on notification for more insightful content. You can also join our exclusive WhatsApp community to get free updates on Lean Six Sigma tools and techniques, everything about Lean Six Sigma. You can master our Lean Six Sigma from our community itself. And stay tuned, because we have more exciting Lean Six Sigma insights coming our way. Thanks for valuable time, and thanks for being part of this journey of the Lean Six Sigma world. So I thank you from the bottom of my heart. Thank you. Thank you so much.